Hello, this is a video designed to show the processes involved in creating an RF survey report. It will go from downloading the raw data that comes in from the field survey all the way up to creating the leadership report. Initially, the RF survey data from the field should arrive in this share folder. It's on the network services, telecom IT shared files, and it's right here under campus RF survey report. Double click on that and come down and find survey buildings, and we're going to use the dairy research as an example. So all of your data will be in here. However, it's to the next step would be to load it into the SeeHawk Collect viewer so you can view the data. However, it's not quite that easy. It's a little bit convoluted process to get that data to work in the SeeHawk Collect. The first little hiccup is that for some odd reason you cannot just take this data off of the shared drive and feed it into the RF survey in the SeeHawk Collect software. For some reason it doesn't work, and you can't. So what you need to do is basically get it onto a non-shared drive, which is your C drive. So for instance, here right off of my C drive, I've created a folder called RF surveys, and then you need to, within whatever you choose, RF surveys is probably a pretty good name for it. This comes right off of Windows. This has to be named drives, specifically for the software to recognize it. So you can call this whatever you want, but you need to create a subfolder within that is named drives, and within that subdrive, within that folder, you can place the folders that we saw in the previous shared drive. However, it's not quite that easy as well, because for some reason the files will not directly transfer from the shared drive into your C drive. There'll be a hiccup, and it will tell you something. It will complain about something about one of the files can't be transferred or something, and I'm not sure what the problem is. So the workaround for that is to grab the data from online and then bring it back in. So it's in its purest state on the online. So from the building folder, you'll have survey results, and within survey results, you'll have a walk test. So just go ahead and right click on it, more options, and then view online. And then you can go ahead, it will show up online, so you can see what you see online. So then from there, all you need to do is just go ahead and download a copy of it. So that will come on over and go into your downloads folder. So once you have it in your download folder, you can just go ahead and copy it and come over to the folder that you created on your C drive, like this. And then what I do is I have a folder outside of it that can kind of hold, kind of like a temporary holding area. Because here you're just going to need to go ahead and extract it. So you can do that, and that will extract it. Then this is what the information that you want. So you would just take this, copy it out of there, and come on over to drives, and then right click and paste it in here, and that will give you what you need. And once you have it in here, then you're ready to roll. So when you have it here, back up to the now we can open up SeeHawk Collect, which is a proprietary software. So each seat for this has to be licensed. So currently we only have this single seat that's on my computer. So you would have to make arrangements to be able to even get this far anyways, to be able to utilize the software. But once you're here, then you have this drive list, which is right here, and then you can right click and then properties, and it will, I have it set so I'm telling it pointed right towards the RF surveys folder on my C drive. Note how it says drives. Drives is a requirement. It won't work. So if you call it drive or drive with an underscore S or something, it won't pick it up. And by picking it up, meaning this is what it's when it's picking it up. So this right here, this drive, it's looking at that folder and it's picking out the different files that are in it that can work for what you want to do for your survey. So it's seen the files that are in there. So for instance, we can go ahead to go to the dairy barn, and then we want to right click on it, and then we're going to want to play it back, and then it's going to give us all of the so it's going to ask us what band we want to look at. So you can only, because it's, so the scanner is scanning all these, I don't know, it's like 25, 28 frequencies every time it does a shot. It records 28 or so different frequency levels or band levels. So you can only look at one at a time, because it wouldn't make any sense to have multiple bands on a one map. So and we'll get into some of the details about that a little later. So you would need to know, this is kind of a cart and a horse type of situation. So you would need to know which bands that you want to zero in on, and which bands to discard. So the ones that you're only going to want to zero in on the top performing bands for any carrier. So you have Verizon, you want their top performing band. You have T-Mobile, you want their best band, and then you'll have AT&T. So you'll need those. There's no sense in looking at underperforming, because you're only interested in who has the best band. So the carriers are going to have multiple bands, and they're going to be all over the place in terms of levels. So, and your phone can sort that out too. So it's just going to look for the best band. Then within the bands, there's technical reasons why it may want to use 2100 versus 700. A lot of it has to do with bandwidth and data and things like that. Mainly on these cellular surveys, we're looking just for raw, straight up cellular. Is his voice, being able to work out of a building. So we don't care if the data is that good or that bad, because that's more on the Wi-Fi end of things anyway. So we're just going to look for the top performing band, no matter what it is. If it's a 700 band, it's probably not going to have as much bandwidth, but it will work fine for voice. So as we move into this video series a little deeper, we're going to discuss how we're going to be able to go through this data and discover which are the top performing bands. So that's a little bit more on the advanced side, but I wanted to start the video with showing how what it looks like when you bring the signals in. So for instance, I know that 5110 is an AT&T band, and it performs well. So I can say map. So I right click, map, and we want to go with a dBm, and we're going to put a label on it, and we're going to say receive power, and then we're going to say OK. So that brings up the map of where the technician walked in the building. You can see a little bit better detail. You can zoom in by just scrolling up the mouse. And then we're going to say, so a trick here is you can say ×8. So if you leave it at ×1, it's going to populate the data at the same speed that the technician walked. So which can take a little while. But if you do ×8, it will go in 8 times as faster. So you can see it populates like this. So kind of long story short, no matter how fast you get this thing, it takes a second for it to populate. So sometimes I'll start that and go do something else that I know how to do, and then come back. There isn't any way that this will just load all the data in at one time. I'm not quite sure why, but this is what it is. So this just helps give a visual representation of what the signal level is. So just looking at this right now, I've got these color codes trying to set up for giving some idea of a color representation to the signal strength. So yellow is its usual, kind of is neutral in the middle, not that great, not that bad type of thing. So so it's minus 72 to minus 98 range, and so we can see as they're walking through here that the signal for AT&T is not terrible. It's definitely got plenty enough to make a phone call, and so that helps you give you some quick analysis of what you're looking at. So it's a lot of visual at this point. When we create, what we would like to do is have this data, each one of these numbers, so we can actually create something a little more quantitative, so to speak, to rate reports and things. And visual is good, but we would also like this in more of a raw data. So how can we get all these numbers out from here? So that's what we're going to talk about next. We see here now the survey is completed. You grabbed a couple of shots outside, which is what we like to do. So this kind of gives us a little bit of a reference in terms of what's the signal level outside versus the signal level inside. And as we can see here, it doesn't make a heck of a big difference. In fact, on this side of the building, it's better. So not having any orientation at this very second, which side, northwest, east, south. Obviously, the signal for AT&T is coming from this side, somewhere over here, because this is actually more inside than it is outside over here. And the reason is this is just a dairy barn, so there's no real any high efficiency windows and brick and things like that. So the signal will tend to penetrate fairly well into the building. That's not usually is not the case because it's a new building with low E-glass and things like that. But in this case, it did work pretty good, and it's pretty obvious the signal is more than likely coming from this direction. And so back as I was originally stating, that we would like to be able to grab a hold of this raw data and perform operations on it. So the survey is over. We've had a good chance. As an aside, usually what I like to do at this point is I'll just go ahead and grab a screenshot of this, and that will give us a reference. So that's this is valid information to have. So what we really would like, excuse me, what we would like to do though is we need to document where we're at with this 5110 band, so we have it as part of this, and this can be included in the report for AT&T for this area. So this is valid information. So let's go ahead and just label this with the 5110, so we can just open it up like in Paint and take oops, I don't want to do that. I want to do with the little text box. So with the text box, I'll just say 5110, and then we can also probably say before that AT&T and Sometimes it's nice to have it in red so it sticks out a little bit. And there you go. So now it's part of the image. Let me just go ahead and save that. And we'll just save it as part of for our RF server report. Right now I'm just going to dump it in the downloads. So I'll just say AT&T 5110. Oops. 51. And just hold it. You can place that anywhere. I'm just looking to save it to move on to the next thing, but we will definitely reference back to that at the end when we're putting our report back together. So now that we're done, we want to make sure we're in manage drives and then come up and hit exit playback, because it won't do a heck of a lot if you don't exit the playback. So that's important. Come back to your drive list. We can, let's see, go to playback, and then we can. So there's two ways to get the data out. The slower way is to do it this way, where you come back to the drives list and you can hit export, and it will walk you through. So it will give you all these options and stuff like that. That's the slow way to do it. So the best way to do it is to totally get out of the software and use a utility that comes with the software. And in the planning and design shared folder under RF survey, there's this utility that you want to download the whole file and put on your computer. And this will allow you to do, it's a much quicker and a lightweight utility. So once you get it, you just run auto export, and it's going to run. And I believe this can be ran, this is license independent. So you can do these without having the SeeHawk license on your machine, which is nice. So it gives you opportunity to do some pretty heavy duty operations on the data without having the license. So that's just going to run, it's just a utility, it's running right here. And it's just sitting there, as it says, it's just waiting. Are some options here, and what you want to do is create, this is important. Once again, the folder names are important, just like it was when you set it up for the SeeHawk Collect. So it's going to say you need 3 folders. One is the drive, so you need a folder named drives, which I have on my desktop. And then within that folder, you have to have one that is named destination, and then you need another folder that's named archive. And so we can take a look at it here, and here's the settings that you'll want to use. You have comma separated value collect, and nothing clicked here. And then this is the way it looks. So you'll have to have it look like this on your machine as well, or it won't work. So you have to have it set up exactly that way. But what it does is it allows you to just bulk take everything and get the raw data out of it. For instance, remember when we created this off of the C drive? So you can just take this whole folder, dairy barn, copy it over to your drives folder and place it in there. And then what this is going to do is it's going to pick up right there. So it's picked up that there's something that has been put in there, and it's going to try to work on that data. It might have got a little upset because I had already a folder with the same name on it in the destination folder. So I think it didn't like it because there's already this folder over there. But that's what's going to happen, is it will create. And so once it does that, it takes all of that data and puts it in a spreadsheet. So now you have a spreadsheet for each one of those bands that they want. So for instance, we had the 5110. So if we open that up, here's all that raw data that was collected by the technician. The latitude and the longitude are just kind of a fake thing because it's an indoor survey, so it can't use true lat and long. So that's why when he's taking data points, he's actually putting points on the map, and the software is connecting them together. But if we do get external drive data, these will be valid, but these are not. But that doesn't matter. What's going to matter is that it just gave us all the raw data for all of those points that we saw on the map. And this is what we need to do some quantitative analysis. So in our next video, we're going to do a deep dive into how we might want to create some pivot tables here and grab the data and do it in a very efficient manner.